Hello everyone, I'm Shafiq Ahmed from Final Year AIT's department. I'm here to talk about my final year project FMD, Forge Model Deploy, an automated and no-code ML deployments software with FastAPI as backend and React as frontend. So here's the introduction to our project. Our project is basically focused on ML and AI engineers who dedicate the time to create models and solve relevant problems. While they spend most of the time in creating, training, and cleaning the models, it would be really hard for them to deploy them so that it can be accessed in a very formal and a public way. So this is a statement of a problem. You want to remove the barriers of ML engineers to have the difficulty of deploying their model by creating a scenario where they have to know front end, back end, and cloud deployments, etc. Our scope of the project includes deployment of ML platform with our own website built using Express as a backend and React as a frontend. Then we also integrated API generations using AI, and we have implemented the CI/CD pipelines too. And our target audience includes ML engineers, researchers, and data scientists. Even non-technical users shall be able to easily access this project. Our inclusions includes our own website and compression of zip files, etc. So this is our methodology. We gathered our requirements with the system design. We made the user flow, and we did first the automated code generation part. Then we did the backend and API generation part. So this is our architecture diagram. Here we can see that the user logs into a particular website. This is the presentation layer where they can log in and add their project. Once the project files are added, it will add the data to the DB, which will be connected to the DB through the backend layer, and it will trigger a Jenkins job. So a Jenkins is automated CI/CD software that runs based on multiple triggers whichever we set. So once Jenkins job is triggered, it will trigger the AI code generation using Gemini API, and it will get the generated code again. After getting the generated code, it will create the EC2 instance using Terraform. Terraform is an open source software used to manage infrastructures as code. Then we use Ansible to build our particular websites based on the code from AI using Ansible. So Ansible is a software that is used to automate things on remote systems, etc. Then once Ansible completes the deployment, it will check and the details of the instance will be added to the DB. Once added to the DB, it will be reflected to the user, and user can easily access their ML models. And this is our use case diagram. As you can see, the user will be able to log in, manage project, upload project, as well as access ML models. And Jenkins will trigger the job, generate AI code, deploy code, and store the instance details. This is our class diagram, and this is our sequence diagram. So our algorithm uses a custom algorithm that we created for Jenkins automation, Terraform provisioning, and backend setup, including using Fast API for users' websites. This is our minimum hardware requirements and software requirements, including the technologies used. This is our important code segments part, which will be looking at VS Code. So here we can see we have 4 folders here. So starting from our own backend, frontend, file generation, and cloud hosting. So this file generation is the part where our AI code is generated. As we can see, it will contain two particular folders to store the generated code, and this generate code does the job of generating the code. So it has particular prompt for generating the backend and a template code to be followed to create the backend. In the same way, there will be a front end, and there will be evaluation to cross check whether the user has uploaded the correct file, and the user's input will be stored here. Now it will be empty, but dynamically after that it will be changed. Once this is completed, the cloud hosting part comes into play, where this main.terraform comes and starts the initialization of an AWS instance basing on our particular AMI ID and instance text. Then our Ansible file kicks in, and this is our Ansible configuration, and this is the Ansible setup. So here it copies the generated backend file from local to EC2. Then it makes some changes in the remote and restarts the backend server, and it will move the created front end file from local to EC2 here, and it will build the front end and deploy it to the Nginx location so that it can be accessed easily. And this is our front end for our particular website where the users will able to log in and deploy the model. And this is the back end for our website. It contains the DB as a JSON file. So we can see these are the so far generated projects and these are the users available. So for a live demo, let's go to the websites we have. So this is the website's front end and this is the website backend developed using Swagger. So here we can see all the routes involved with their parameters and their request bodies. So if we go here, I can see the request body is a project zip file. If I want to put a project up, I can see these are the required thing I have to follow, and the schema is also included. And this is the Jenkins. So this Jenkins automates the entire process. The Jenkins is configured with an Groovy script. The Groovy script contains what exactly needs to be done. So here we can see first it clones the repository, then it downloads the file from the backend, then it runs the AI code generation part, then it gets the Terraform to be activated, and it will get the Terraform output. So now we can start with the live demo. First, we can log in with the user ID and password. They can see a preview of the projects they have deployed before, and they can create a new project here or here. They can also visit their new profile and they can update it as they want. If they go to deploy model, class some details. We can say test and deployment, checking for YouTube presentation. We can choose a framework as a linear regression, and currently we have only scikit model. Then we can choose our projects here. If I go over to documents, I have a project that I've done previously. So here is the Jupyter notebook file, a requirements or text file, the saved model file as a pickle file, and the data set as an XLS file or a CSV file. If I click upload, it will start the initiating deployment using Jenkins and it will redirect us to the deployment page in 10 seconds. So now we can expect it to be moved to another page. Here we can see the deployment status and it will show a timer of how long it is taking. In the meantime, if you go over here, we can see this particular Jenkins job has started. So it is estimated to be completed within 3 minutes and 53 seconds and it started around 11 seconds ago. So we can wait here until gets completed. Welcome back. Now we can see the job is nearly going to complete. We can go over to Jenkins and see the logs that we have here. So it's going. We can see it got the backend file here using backend route. We can see it got the zip file from the backend and that extracted here. And it has used the Gemini API here and it has generated the entire prompt file, sent it to generated code, and it writes the responses to files and everything. And these files will be used to deployment. And we can see here the Terraform is initiated. Terraform starts the deployment here. So here we can see it is setting up the application, and now it's copying the backend file to EC2 instance. Then it's restarting the server, and now it's installing the packages at the front end location. It's still going on. So now it's creating the API route file for the backend to access for the front end to access the backend within the EC2 instance. Now it's copying the AI generated file from local to the cloud instance. You can see 2 and 30 minutes here, but nearly 4 minutes here. This is because this minute is only accounted for the amount of time that Ansible takes to deploy our software, and this is the entire time from the user submission to user getting the IP. Here we can see the front end is being built and being moved to the Nginx location. We have our server as Nginx. Now we are restarting the server, which is the last part of our deployment process. Now we can say it's completed and we got the IP here and the job is finished and it's success. If we go over to our page, we can see the job has completed successfully and it is deployed to the IP. We can copy and go over to this IP to check our website. So we can see it is connected to the backend. It is online. Since it was a categorical field, it has automatically generated a drop down field for us. So we can interact with this and make predictions. And it has included some basic metrics that were included in the IPYMB file. We can also go over to the dashboard, go to the particular project, and we'll have a small iframe of the particular deployment we have made. For example, this was the previous project that we did, and this was another project that we did. So here it is a different metrics and different project. If we enter our hours of study, it will predict around 99 marks I could get and everything. We can also download the files here or open it in a new tab. So if you open it in a new tab, it will automatically redirect us to the website here. So here we can see the API status also and our particular project, which is also named by AI. So that is for this presentation. We have included some basic outputs here, some basic output screenshots at sample test cases, RSS, and our conclusion. We have some future works by including multiple ML frameworks and containerizing the entire process and adding monitoring and logging within our website so that users don't have to go to AWS to see the things. And we have covered two sustainable goals. And one is industry innovation and infrastructure by reducing the technical barriers for ML engineers. And we have covered the quality education goals where we try to simplify the ML deployment process and make this process as interactive as possible. So here is a list of our references. Thank you.